everybody, this is Ms. Bufford, and this video covers building block 7 from Unit 12 over solutions. In this building block, we're going to cover molarity and dilutions. Your learning goals for building block 7A over molarity are going to be to calculate the molarity of a solution given moles or mass of solute, and to be able to calculate the mass of solute needed to prepare a solution of known molarity. All right, so we need to talk about what molarity is. Molarity is a way of expressing the concentration of a solution. Specifically, we use moles of solute over liters of the solution. And we use the volume of the solution rather than the volume of the solvent here because the solution or the solute contributes some volume in a solution, and that needs to be accounted for. Molarity itself is useful if we need to know exactly how much solute we're dealing with. For example, if I had a solution of a specific concentration, knowing what the concentration of that solution is would allow me to be able to calculate what volume of that solution I would need if I needed a specific amount of solute. We can also use this information to calculate and perform dilutions of concentrated solutions, which we're going to do later in this building block. Before we start our calculation examples, I wanted to go ahead and give you guys a little overview of how we actually create solutions that have specific concentrations or specific molarities. The equipment that we use are volumetric flasks, and a volumetric flask is calibrated to a single volume. So if you take a look at the ones in this picture, this particular volumetric flask is calibrated to measure exactly 500 milliliters of solution if you fill it up to that little mark that's on that long stem neck right there. The way that we want to do this is if you know the specific concentration you're looking for and you know how many moles you're going to need, then you're going to convert your moles into grams and use that mass to measure out the mass of the solute that you need. And then you're going to add that solute into the dry volumetric flask. And then you're just going to add a little bit of your solvent, just enough to kind of completely dissolve your solute. And once that's been completely dissolved, then you're going to put the volumetric flask down on a flat surface and continue to fill it until you reach that mark. You want to get down eye level and make sure that that meniscus, the bottom of the meniscus, is right on that mark. And that's how you make a very specific concentration of a solution. All right, so let's go ahead and do some example calculations. And after these examples, we're going to come back and continue with our discussion on dilutions. All right, so we're going to go ahead and do some molarity calculations. The first two that we're going to do are pretty straightforward molarity calculations, and the rest of them we're actually going to be using molarity to determine a volume or an amount of moles or something like that. One other thing that I'd like to say is that sometimes the way that these problems are worded leaves you feeling like you've got to do something extra or something special in order to solve that particular problem. And I'm going to show you a way to kind of cut through that a little bit. So let's go ahead and get started with this first one. What I'm actually going to do is, this is my trick here, I'm going to go ahead and make a list of 3 different things I need to know for this problem. I need to know molarity, I need to know moles, and I need to know volume. These are the 3 things. This is my trick for cutting through all of that confusion that sometimes the wording of these problems makes you feel. So if we can go ahead and write something down for each one of these, given the information from the problem, then it makes it a little bit easier to see what we need to do. So let's read through the problem. What is the molarity of a 1.50 liter solution containing 6.0 moles of sodium chloride? So right off the bat, I know I need molarity. It's asking me to calculate that, so that's going to be my question mark. And I know that units of molarity are moles over liters. Okay. Then it says I have a 1.50 liter solution, so 1.50 liter solution containing 6.0 moles. 6.0 moles, and that's NaCl. Okay, so it's asking for molarity, and I know because the units of molarity are moles over liters that I'm going to divide moles by liters. So over here, I'm going to write 6.0 moles, and I'm going to divide that by my volume, 1.50 liters. And that, if I put in my calculator, will be 4.0 moles over liters. And since I know that units of molarity are moles over liters, I'm going to rewrite that as 4.0 molar. And there's my final answer. There's the molarity of this solution. Okay? Let's go ahead and do the second one. Again, I'm going to list out molar, moles, and volume. Okay? And so let's go ahead and calculate or read through the problem. What is the molarity of a solution of nitric acid? So HNO3 is called nitric acid that contains 12.6 grams of nitric acid in a 0.10 liters of solution. So let's go ahead and fill in my information down here. Again, it's asking for molarity, so that's going to be my question mark. And I know units of molarity are moles per liter. And it's telling me that I have 12.6 grams. So I'm going to go ahead and write 12.6 grams, but I know I'm going to have to convert that to moles, and I do that conversion by dividing by the molar mass for that substance, and the molar mass of nitric acid is 63.0 grams for 1 mole. So grams will cancel out, and that leaves me with 0.200 moles, and that's HNO3. Okay. And then it's also telling me that I have 0.10 liters of solution. And again, when I'm calculating molarity, it's always going to be moles over liters. So I'm going to put 0.200 moles on top, and I'm going to divide that by my volume, 0.10 liters. And when I put that into the calculator, that tells me that I have a 2.0, and I just want 2 significant digits because this one has 2 and this one has 3, and we're going to go with the smallest. So that's going to be moles over liters, and since I know that's molarity, I'm going to rewrite that as 2.0 molar. All right, so there's the first pretty straightforward question, or the second straightforward question, the first two. Now let's go ahead and do number 3. Again, I'm going to do the same thing I did with the top two. I need molarity, moles, and volume. All right, so this question says how many moles of sucrose are dissolved in 250 milliliters of solution if the solution's concentration is 0.150 moles, or molar, excuse me. So it's telling me what the molarity is, so I'm going to write 0.150, and I'm just going to go ahead and write out the units the long way, moles per liter. And it's asking me to calculate moles, so that's going to be my question mark. And then it's telling me that my volume, the volume involved here is I have 250 milliliters of solution. And there's one problem with that volume, and the problem is that it's listed in milliliters, and molarity is always expressed in units of liters. So we're going to have to convert 250 milliliters to liters. We'll use some dimensional analysis to do that real quick. So I know that there are 1,000 milliliters in 1 liter. So basically, if I divide that by 1,000, I can just move that decimal place over 3 spaces, and I've got 0.25 liters. Okay? And I started with 2 sig figs, so I want to make sure my volume has 2 sig figs over here. All right, so when we have a problem like this, where either moles or volume is our unknown, we're always going to start with either moles or volume. And since I know volume in this case, I'm going to start with my volume. I have 0.25 liters. Okay, and I'm going to use my concentration to cancel out liters. I'm using it as a conversion factor, and I'm going to use it to cancel out liters. And when I cancel liters out, I'll be left with units of moles, and that's what I'm looking for here. So I'm going to set this up over here like a conversion factor, and I have, let's see, 0.150 moles for every 1 liter. And if I do that math in my calculator, I end up with 0.03 and sig figs 8 moles of sucrose. And there's my final answer. That's how much sucrose was dissolved in that solution. Okay, so now let's go ahead and go down to this one. Again, I'm going to start with molarity, moles, and volume. All right, and this problem says how many grams of potassium nitrate are required to prepare a 0.250 liters solution, liters of a 0.700 molar solution. All right, so here it's asking for grams, and the one unit that's closest to grams here is going to be our mole. And so I'm going to go ahead and say that this is my question mark, but then I need to convert it to grams. So I need to figure out how many moles I have, and then I need to convert moles to grams. Okay, so let's fill in the rest of the information. The molarity of this solution is 0.700 moles per liter, and my volume is 0.250 liters. Okay, and again, these are my single unit numbers. My volume is in liters, and my moles is in moles. So I'm going to go ahead and start with my volume for this calculation. So 0.250 liters. And I'm going to set up my molarity so that liters cancels out and it leaves me with moles. All right, and when I do this calculation, that's going to tell me that I have 0.175 moles of potassium nitrate. And actually the formula for potassium nitrate is KNO3, and we're going to use that. We're going to need that because we need the molar mass of that substance to be able to convert from moles to grams. Right? So I'm going to take my answer here. I'll rewrite it up here. 0.175 moles. And I need to convert that to grams. So 1 mole of potassium nitrate has a molar mass of 101.11 grams. And if I put that in my calculator, it tells me I have 17.7 grams of KNO3. And there is my final answer right there. Okay. All right, now let's do number 5. This is our last one. Again, molarity, moles, and volume. And this problem says how many liters of solution can be produced from 2.5 moles of solute if a 2.0 molar solution is needed. So I'm just trying to figure out how much, what the final volume of my solution is going to be. So volume is going to be my question mark. I know that I have 2.5 moles, and my goal is to end up with a solution that has a 2.0 molar concentration, so moles per liter, 2.0 moles per liter. So I'm going to start with moles this time, and I have 2.5 moles. And I'm going to use my molarity as a conversion factor. And this time, I want to make sure moles is going to cancel out and it's going to leave me with liters. So remember we talked before about being able to flip conversion factors. And so I'm going to put the moles on the bottom here. So 2.0 moles for every 1 liter. Moles will cancel out, and that'll leave me with units of liters. And if I do that math in my calculator, it tells me I have 1.25 liters. That's my volume. That's the volume that I'm going to need. All right. So I hope these examples were helpful. If you have any questions, please feel free to message me through It's Learning during my office hours between 10 and 11 a.m. Monday through Friday, or you're welcome to send me an email and I'll try to get back to you as soon as I can.